basically from work, power and energy, okay, where it's given that a moving car encounters some air resistance, right? So the moving car which encounters the air resistance, let's say this is the car, let's say this is the car when moving forward, okay, then it encounters some resistance by the air, right? Air is flowing into the opposite direction, okay. So let me zoom a little, right? So we can say that the air which is coming from the opposite direction will restricting the velocity of the car, right? This is the velocity of the car, right? Now the question is giving that a moving car encounters air resistance which is proportional to the square of the speed of the car. So this air resistance, this resistance, this air resistance is, this is proportional to the square of the speed of the car. So this proportionality is given to you, right? Where v is the velocity of your automobile or car, right? Now the ratio of the power required at 40 km per hour to that required at 80 km per hour is what? So let's say if the velocity, the values of two velocities are given to you, then the ratio of the power we need to find, right? To find that we need to understand one formula, that is the what is the average power, right? The average power, the average power can be written as work done per unit time, right? This is power, right? Now, and what is this, and how, what is this work? Work is force F dot S, right? Because if you remember, I'm just quickly going through this. If the mass is here and we are applying a force on it which is acting at an angle theta from the horizontal, and this mass is moved by a distance of S, then we can say that the work done is F dot S, right? But dot S, that means this is the dot product, that is Fs cos theta, right? So from here we can write, this can be further written as F dot V by T, isn't it? S can be written as V by T, right? S can be written as this T which is already present over here, this S by T can be converted into this V, right? So you can see that power is F dot V, right? Power is proportional to the velocity, right? So here we can see power is proportional to the velocity. So this is one of the relation, right? Now here into the question it has been given that a moving car encounters the air resistance, here the air resistance which is proportional to the square of the speed of the car, right? Now this is given that this air resistance is proportional to the square of the speed of the car, right? Now we need to find the ratio of the power required at 40 kilometer per hour. So 40 kilometer per hour, let me squeeze a little, yeah. So two velocity is given to you, one is 40 kilometer per hour, right? And another is, this is v1, let's say, and another is v2, which is given to you as 80 kilometer per hour. Now we need to find the ratio of the power required in between these two cases, right? So if P1 will be the power for the first case, then P2 will be the power for the second case, right? So here we can say that if we also know that the P is the product of F and V, right? P is power is the dot product of F and V. So it can be written as F dot V, right? Which we already shown how it can be. Okay. Power is F dot V. That can be written, right? And this air resistance, that means this is some force. This is some force. And this is proportional to the V square of the automobile or the car, right? So this F, since F is proportional to V square, this F is nothing but air resistance. This F is nothing but air resistance. This is proportional to V square. So can't we write that? Then we can write that power is already having one velocity, and if the F is there, this will give two more velocities, right? So we can't we say that P is having V square and V power 1, right? So we can say that it's saying proportional. So we need to apply the proportionality sign. So we can say that power is proportional to V cube, right? This is V cube. So this is the relation which we are having. Now we have two values of power, right? We have two values of power which need to be calculated for these two velocities V1 and V2. Now, what is the ratio of these two power? This has been asked. That is, what is the ratio of P1 by P2, right? P1 by P2 will be nothing but this is the ratio of corresponding velocities, that is V1 and V2, and it's in cube, mind it, it's in cube. Okay, so P1 by P2 will be proportional to the ratio of V1 cube by, tell me, V2 cube, isn't it? V1 cube and V2 cube. And what is the value of V1? V1 is nothing but 40. You can see here 40. V1 is nothing but 40. So it's 40 cube. So 40 into 40 into 40 will be into the numerator, and into the denominator it will be V2 cube. So what is V2? V2 is 80 kilometer per hour, right? So this will be into the denominator will be 80 into 80 into 80. So this will give you the ratio of P1 and P2. So here you can see these three zeros will be cancelled out by these three zeros, right? And this 4 2 times and 4 2 times 4 2 times. So that means this 4 will be deducting this 8 in 2 times. This 8 will also deducted in 2 times and 2 times. And this 4 4 4 cancelled out. So this will be giving you P1 by P2 as 1 by 2 into 2 into 2, right? That is 1 by 8. So we can say that the ratio of P1 is to P2 is 1 is to 8. Here you can see 2 into 2 into 2 will be 8, right? Hi Mr. Lord, right? So in this way we have solved this question, right? And our answer is the ratio of the powers is 1:8, right? This is our answer. 1:8 is our answer. So again reading the question so that you can collect it easily. A moving car encounters air resistance which is proportional to the square of the speed of the car. That means this is air resistance force. This force, air resistance, is that means some force is applied. This air is applying some force and trying to restrict the flow of this car, right? This car. So this is giving is proportional to the square of the velocity or speed of the car. The ratio of the power required at 40 km per hour to that of 80 km per hour, that was required to be calculated, and we have calculated its answer is 1 by 8. So 1 by 8 is your answer, right? Now coming to the second part of the question. So the second part of the question, question number 2, our question number 2 is that an automobile moving with a velocity of 30 km per hour is stopped in 8 meter by applying brakes, right? So here also it's given that an automobile is given to you, right? An automobile is given to you. Let's say this is the automobile, right? And it applied brake and it just stopped after some distance. Let's say it applied brake and stopped here, right? So the automobile moving at a velocity of 30 km per hour. So here V is given as 30 km per hour, right? Now is stopped in 8 meter by applying brakes. So in 8 meter of distance, suppose brake is applied at this point, then car stops at this point. So these points are let's when brake start applying from A, then finally car stopped at B, right? So after 8 meter of distance, this car stopped, right? Now what is asked into the question is that if the same automobile were traveling at 60 km per hour, then with the same braking power, the automobile can be stopped with a distance of what? So that means if let's say V1 is given to you, now here S1 is given as 8 meter. So two figures are given for case 1. This is case 1, right? When velocity and distance is given to you, right? This is case 1. This is case 1. Now into the case 2, into the scenario 2, what is happening? Into the scenario 2, it has been asked that if the velocity is, let's say V2 is given to you as 60 km per hour. This is 60 km per hour, right? Then in this case, what will be the value of S2? After how much distance the car will be stopped when the car was moving with a velocity of 60 km per hour, right? Into this question, we can say that the car is moving with a velocity, so the kinetic energy will be half mv square, isn't it? Tell me, half mv square, right? And this will be equated with the applied force applied and distance. The braking power is equal to force multiplied with the distance, right? F dot S, we already know it. This is the braking power, right? This is braking power or braking energy, F dot S, right? Now here we can say that half MVA square is equal to F dot S, right? And from here we can see that S can be said as directly proportional to VA square, right? S is directly proportional to VA square. So from here we can write, you can see VA square and S. You can see this relation. So we can say that S is directly proportional to VA square. Then definitely if S is S1 and V is V1, then their corresponding ratios will also be the same. That means S1 by S2 will be equal to V1 by, tell me, V2 and square, right? So here you can see S1, since S1 is proportional to V square, so S1 by S2, the ratio of S1 and S2 will also be the ratio will also be the then in this case this ratio will be equal to the ratio of the V1 square and V2 square, right? So what is V1? V1 is nothing but 30 and V2 is nothing but 60. So this will be giving you, just put up the value of V1 from here, right? That is 30. So this will give you 30 square, right? And V2, this V2 is put over here, that is 60 square. So this will give you the value of S2 as, because S1 is known to you as 8 meter, just put it over here, right? Then what you can see, S2 can be written as S1, that is 8 meter, 8 into 60 into 60. This 60 will be going to the numerator of and multiplied with S1, right? Divided by 30 into 30. So here you can see these two zeros will be cancelled out with these two zeros, and these 3 and these 3 will be cutting this 6 and 6 in 2 and 2 times. So S2, the value of S2 is coming as 8 into 2 into 2 meter. 8 into 2 into 2 meter. So this will be coming as 32 meter. So here you can see, if the velocity is increased from 30 to 60, if the velocity is double, then the distance in which the automobile is stopping by applying the brake will be quadrupled, because you can see here 8 meter, you can see here 32 meter. So 8 and 32, 4 times quadrupled. It's quadrupled, you can see. You can see here. So if velocity is doubled, then this automobile will stop with the same braking power. The condition is that with the same braking power, the automobile will be stopped, and the corresponding ratio of the displacement or the distance of stopping, this one, will be quadrupled. That means it becomes 4 times. Oh my god, 4 times. So you can see, that means though the speed is higher into the second case, but the car is taking long time, long distance to travel and stopping. So because you can see, if the car was traveling at 30 kilometer per hour, then in just 8 minutes it stopped. Here, this after applying the brake, it reaches to a point B, and brake was started applying at A here. So in just 8 meter it stopped. But when the velocity is increased from 30 to 60, this one, then it takes 32 meter to stop. So that means if the car is here from A, it crosses B, it crosses C, it crosses D, and it stopped at E point here. That means this distance 1, 2, 3, 4. 4 times quadrupled. This is quadrupled. Okay. So students, hi Mr. Lord. Hello. Hope you find this today's session useful. If you find it useful, you can just like and be connected. Thank you so much for watching. Take care. Bye bye. See you.